Good morning, good afternoon. We're going to be 2.4. Will be day 1. We're going to be working with solving equations with variables on each side or both sides. Our I can statements, or I can solve equations with variables on both sides, and I can write equations needed to solve word problems. We're going to continuously work with word problems. Again, this is in 2 days. The first part, we need to I know your notes, if you look at your notes, it's kind of, they are kind of light, so what I would ask of you is that you pause the video, write down the notes, make sure that you have all the words and you know all the words. Term is our first word. It's going to be the parts of an expression or equation that are being added together. So even if you have a minus here, it's still, you can combine them together. And then like terms are terms that have the same variable parts. Constants and are like terms, so numbers that are just numbers. Okay. So here, the 5 and the 3, remember that whatever is in front of it, whatever the sign is in front of it, that means that this is negative. And then here, there's no sign in front of it, so it's positive. So those two are constants, so they are like terms. And then the 2x and the positive x, those are like terms also. Just remember that, say, 2x and x squared. These two are not like terms because they are the same letter, but they don't have the same exponent. Right here, this is an invisible 1. This one is a 2, so they don't have the same exponent. It has to be the same. Same with x and y. They are different letters, so they would be different terms. They're not like terms. X and 2x, those would be. We're not worried about the coefficient or the one connected to it when deciding if they're like terms. Like terms are just going to be the same variable raised to the same power. And combining them, remember when we did our algebra tiles, if I have 1x, I could draw it out, right, like this. Sorry, and then if I combine it with 2x's, now I have 3x's. And really what I'm doing is when I combine them, I combine their coefficients, so I add them together. I also like to say, if you are talking about x's or the variable, think of it as apples. 2 apples plus 1 apple equals 3 apples. And then you just replace apples again with that x or whatever it is. All right, so we have some rules. Again, I would pause the video and make sure you can read all of your rules. Solving equations with variables on both sides of your equal sign. First, you want to combine any like terms that are on the same side of the equal sign. Second, you want to add or subtract the smaller variable term to get variables on the same side. Add or subtract the constant, multiply or divide it to isolate the variable, and then write the answer as variable equals. So, a lot of the times I will say, you want to get all your terms on one side of your equal sign, and you want to get all your numbers or your constants on the other. So apples on one side, oranges on the other. So the terms that are the same. So if I look here, I have a 4D on this side, but an 8. These I cannot combine together because I need both of them to have a D to combine together. But these two are like terms, but they're on either side of your equal sign. So I want to get rid of this positive 4D. So I want to subtract the 4D. So I need to do the opposite so that this will go away. Well, if I do it to one side, I have to stay equal and do it to the other. So now I have 5D minus 4D. So here, 5 minus 4. It's really what you're going to do, and that equals 1. And that variable just stays with it. Thinking of algebra tiles, I have 5 D's, and I'm subtracting or taking away 4. How many do I have left? I have 1 left. This will go away, and all I have left is that 8. So that means 8 is equal to 1D. Again, this 1 is not necessary. I want to get isolate my variable or have it be multiplied by 1. It's the same thing. And then I want to always write it where the variable is first, so D equals 8. And that is my answer. Let's go on and try another one. So in this example, it always said, start with your smaller variable, like coefficient. Well, if I were to subtract 5a, and I can do that, I would subtract 5a over here. The only reason I want to do that, and it's not completely necessary, but the reason I want to do that is so that my a stays positive. So I have 3a. This and this go away. If there's nothing left, there's nothing left. It's 0. Then equals, and then 21 stays on this side. And then I want to get my 21 away from this side. My goal is to get my variable equals, so minus or subtract 21 on both sides. So here, 0 minus 21 is just a negative 21 equals 3a. So again, I have now a variable multiplied by 3 equals negative 21. So I need to undo that by dividing by 3 on both sides. That equals 1, and that's what my goal is, 1a. So a, because that goes away, negative 21 divided by 3, and negative divided by a positive is a negative. 21 divided by 3 is 7. So there again is my answer, where I want to write it as a equals a negative 7. Can't see that, can you? Okay, let's do more. Now I have, I want to look at these and just do, we're going to circle our constants. So if you see, my constants are the numbers that do not have any variables. So those are my constants, and I'm going to square or put a square around my variables. So those are like terms, but they are on either side of the equal sign. So I need to add or subtract to get all the variables on one side and all the constants on the other. So I want to look for my smaller coefficient on the variable. So 4 is smaller, so I'm going to subtract 4n first from both sides. This gets rid of that, because 4 minus 4 goes away. That means that only this negative 5 is left. Now I have 6n minus 4n becomes 2n, and that minus 1 still. Okay, then I want to get rid of that minus 1 on this side. So if I look on the right side, I got rid of my variable. So on the left side, I want to get rid of my constant. So I want to add 1 to both sides, making sure whatever I do to one side, I had to do to the other. Negative 1 plus 1 becomes 0. Anything plus 0 is self, so I don't even need to write that. That goes away. 2n is left. Negative 5 plus 1, again, using a calculator, double check my answer, but negative 4. Okay, then I have 2, or I have a coefficient. I need to divide by that coefficient to get rid of it, and I have to do the same on the other side. So I get n equals a negative 2. And that is my answer. Okay, on this one. Now, this is why it's really nice to work and do lots of work with these, because you'll get really good at doing them different ways, but the easiest way would be to subtract your smaller variable term from both sides. That goes away. I have negative 7 left, remembering that whatever the sign is in front of it, that has to come with it. equals 8 minus 3 is 5x plus 23. Nothing has changed with these. Again, I can't combine the 23 and the negative 3 because they're not like terms. But I will want to subtract my 23 from this side and then from this side. And negative 7 minus 23 is a negative 30. That equals, this goes away, 5x is left. So I want to divide both sides by 5. Negative 30 divided by 5 is a negative 6 equals x. So I want to write x equals a negative 6. Okay. Next one. All right. This next one, we have fractions, and I know that a lot of us do not like fractions. So what I want to do right off the bat is I want to get rid of the fractions. So what's going to happen is we are going to change these so that they all have the same denominator. If they all have the same denominator, I can get rid of every single one. So that's what we want to do. So if you look here, my denominator is 5 and 5. So I need to make this a fraction first. And to make a whole number a fraction, I'm just going to put it over 1. And then I'm going to multiply it by 5 to make it 5 on the bottom. But whatever I do to the bottom, I have to do to the top. So 15 times 5, you can take a calculator and check your work. 15 times 5 is 75. Oh, can't see that. But now, everything else is going to stay the same. That 3 fifths x minus 75 fifths equals, again, that 6 fifths 5x. And then here, I want to make this a 5, so I need to multiply it by 5. I have to do the same to the top, so this would be 60. Now if you look, I mean, this is a fraction. 60 divided by 5, is that 12? Yes. I haven't changed anything, except I made everything have a denominator of 5. Now, if they all have the same denominator, they can all go away. I'm going to cross them all out, and everything else, that fraction goes away. So now it's 3x, 3 times x now, minus 75 equals 6x plus 60. So we are going to add 75 to both sides. This goes away. I get 3x equals, that 6x I didn't do anything with. This would be 135. Then I need to subtract that 6x from both sides. So 3 minus 6 is a negative 3x equals 135. And I need to divide. I'm going to rewrite it over here. Negative 3x equals 135. I need to divide both sides by a negative 3. 135 divided by a negative, again, negative 3, negative 45. So x equals a negative 45. And that would be my answer. Okay, so I have about a minute left. I'm going to start another video. You need to watch both videos today for the day 1, 2.4.